let's talk about major networking concepts. Some of the major components of networkings are TCP/IP, protocols, routing, routers, and also the client-server model. So let's see what is a protocol. As we have talked about it before, protocols are needed, are the rules that electronic devices use to actually exchange information. People need a common language to communicate, same as computers. They need to have same protocols that they can deal with and connect with each other. And also they should use these protocols to be able to transmit data and transfer files. Protocols also specify the format of the message packet sends between the computers. In today's network, multiple protocol support is becoming more important as networks need to support protocols of computers running different operating systems such as Mac operating system, Linux, Unix, and as well as Windows. So what is the Transmission Control Protocol and Internet Protocol, or what we know as TCP/IP? TCP/IP is an industry standard suite of communication protocol. The main advantage is that it enables the interoperability that allows the linkage of devices running on many different platforms. TCP/IP was originally intended for Internet communication, but because it also addresses issues such as portability, it also becomes the standard protocol for Unix network communication. Two of the major protocols in the TCP/IP suite are Transmission Control Protocol, or what we call TCP, which operates at the OSI model's transport layer. And the other one is the Internet Protocol, which operates at the OSI model's network layer. TCP, which the primary functions are establishing a link between hosts and making sure that the message has the integrity, sequencing and acknowledging the packet delivery, and also regulating the data flow between source and destination nodes. IP, on the other hand, which we call operates at the network layer, is responsible for packet forwarding. It can be divided into two parts, the network address as well as node address. An IP address consists of 4 bytes in IPv4, or IPv6, it's 32 bits or 128 bits. It can also be divided into two parts, a network address and as well as node address. Computers on the same network must use the same network address, but each computer must have their own unique address. IP network combines the network address and the node address into one IP address. For example, 131.255.0.0 is a valid IP address. Second part that we're going to talk about is routing. In routing, we have to deal with packet as well as the routing. Packet is collection of binary digits sent from computer to computer over a network. It includes a message, data, and control characteristic for formatting and transmitting. Routing is the process of deciding which path data takes, and it determines by the type of network and the software that is being used to transmit the data. There are decisions in order to decide which route to select and which route to follow. Decision about selecting a route to follow is done at a central location or each node. We have centralized routing as well as distributed routing. In centralized routing, single node is in charge of selecting the path for all the packets, and in distributed routing relies on each node to be able to calculate the best route that is possible for that packet to travel. We have routing table which generates automatically by some software. It can determine the best possible route for a packet to pick and follow that direction. Distributed routing eliminates the problem caused by having the routing table at a centralized site. If one node is not operational, routing table at the other nodes are being updated, and then the packet is being sent along a different path. So what is a router? Router is a network connection device containing software that connects network systems and controls the traffic flow between them. Networks being connected can be operating on different protocols, but they must use a common routing protocol. Cisco System and Juniper Networks are basically the two major routing vendors that are out there. Router performs the same function as a bridge, but is more sophisticated device. Router can also choose the best possible path for packet based on distance or cost. It can also prevent the network jam that delay packet delivery, and they can handle packets of different sizes. A router can also be used to isolate a portion of LAN from the rest of the network. This process is being called segmenting. For example, if we want to keep information about the new product development isolated from the rest of the network, we can use that segmenting for confidentiality reasons. There are two types of routers, static and dynamic. A static router requires the network routing manager to give it information about which address are on which network. Dynamic ones can build tables that identify addresses on each network. Dynamic routers are used more often now, particularly over the internet. Okay, now let's look at what is a client-server model. In the client-server model, soft runs on the local computer, the client, and communicates with the remote server to request information. A server, which is a remote computer on the network that provides information in response to the client request. For example, maybe on the client computer we want to make a request to show all of the IT students that are enrolled this semester. The database server receives our request, processes it, and then it returns the following names that we wanted to see. In the most client-server configuration, normally there are a series of events that happens. First, the user runs client software to create that query. Then after that, the client accepts the request and format it so that the server can understand. Then the client sends the request to the server over the network, and then the server receives and processes that query, and then the results are being sent to the client. The results are then being formatted and displayed to the users in some understandable format. There are some advantages to the client-server architecture. One of them is scalability, which means that the ability to grow. Client-server architecture, they can be scaled horizontally as well as vertically. What does the horizontal scaling means? It means that adding more workstations or basically client to it. What is a vertical scaling? It means that migrating the network to a larger, faster server. To understand the client-server architecture better, we can think in terms of the three levels of logic. One is presentation logic. Second one is the application. And the third one is data management logic. The presentation logic, which is at the top level, is concerned with how data is returned to the user. That's in the graphical user interface, for example. In the application logic is concerned with the software processing request for the user. And the data management logic concerns with the data management and storage operation.